and start the lecture. I think I go on a tangential direction to basically wait for students to join in, and I think it's been 10 minutes and more. So what we'll do today is to continue what we left off from Tuesday. But before we go there, let's do a quick recap because this is one of the most confusing topic for this class basically, and like C 101, basically like introduction to C. We talked about on Tuesday. We talked about data versus addresses. I think I'm about to have here, so I just want to make sure he or she doesn't interrupt the lecture. So when I said int a equals 10, right? What it really means is I define a new variable called a, right? And I assign the value 10 to the variable, right? So the variable a will store the data 10. And then if I want to get the address, because every single piece of your data, right, it needs to have somewhere it belongs where you can store the data. Because I mean, data are physical thing. It's actually like electrons in a capacitor somewhere on your computer, right? So you need an address. Why do you need an address? So that you can go back and access the data, right? As simple as that. We're not going to go into the technicality of the virtual address yet because that's the next module. But once we're done, I'll bring everything together. Basically, I'll make sure that it doesn't confuse you, as in what would happen when I access my data. This is something that's missing when I was taking this version of C class at CMU, to be honest, like putting everything together. So I want to make sure I do that. How to use pointer. So pointer store the address, right? So I can define something like int star a. This is actually syntactically wrong. Can someone tell me why this is actually wrong? So if I compile this code, it will give me an error, but why? Anyone want to make a guess? So a hint is, what would be the initial value of my pointer? I guess hint number 2. What is a pointer? Can someone tell me what is a pointer? What does a pointer store? Yeah, it store an address, right? Um, the thing is, if I define a new variable, what would be the starting value? Some random number, right? Or 0, something, right? So what would be the starting value of this address? Something. It can be null, it can be random address, right? Depending on what version of GCC you're using. So let me ask you this. Does the program own that address actually? Or is it maybe someone else's address? Or is it maybe actually invalid address? Because A store the address, right? So in this case, is it invalid? Is the address invalid? It should be invalid, right? I mean, think about it this way. Let's say I create 2 pointers, right? And both of them point to a value 0. It get initialized to value 0. Then who owns that value 0? Because if you do that for every single program, it basically means that now every single program trying to point to that location, right? So who owns that, right? So these are invalid. The safest thing you can do is make sure that that place is invalid. Like now, it can be now, it can be something that is you did not own, right? So you can't really say, hey, go to that location and store the value 10. Because it's basically the same as you go and break into someone's house and put your items in there, right? What would happen to you in that case? Someone would call a cop, right? And you get kicked out of that house, right? In the case of the computer, right, it would basically the process would get killed. Right? The program you're running that try to walk into someone else's home, it will get killed. Right? The OS will come in and make sure the program stop running. So basically, let's assume this is valid. Like syntactic reason, it's not valid, but let's assume it's valid. In this case, the address point to the location that has the data 10, right? So star A would have the value 10. And then you can use the ampersand and the star interchangeably. The ampersand will get you an address. The star would get you the value of the address. And you can make pointer also point to other variable. You can also do operation on a pointer like increment, right? So we kind of end the lecture kind of right there, right? And now let's move on to memory allocation. Metas, are you back? You said you want to. Is he here? He said he wants to like rejoin. Okay, you're here. Awesome. So I can move on. I don't know. Someone left because the number of participant dropped by one, so I thought it was you. So let's talk memory allocation then, right? The method to get the LAN for our data, right? The computer is nice. LAN can be called, and I can actually acquire LAN, right? Unlike Bangkok, where LAN is scarce and everything is so expensive. Yeah, you can write a program and take many of the free space, right? And hawk all the land from other program, become a lord, right? I mean, what would happen in that case? Let's actually go there. Let's actually go there. It's kind of like fun discussion anyway. So let's say I have 5 programs, and one of the program keep asking for more land. What would happen? So it actually would start to run out, the computer would start to run out of memory, right? So let's say I have program A, B, C, D, and E, right? And program A start to acquire more and more land, right? What it means is, what would happen to program B, C, D, and E? You can acquire land as well, right? So the OS, the computer will try to like assign everyone's land and make everyone happy, right? But the thing is, your memory is limited, right? And we have discussed a little bit earlier about paging. Basically, when all the program use more memory than what your actual DRAM has, you'll start to use hard disk for your data, right? To store your data in a memory, but it's now stored on a hard drive. At that point, everyone will get to the point where things are slow, right? So one thing I can do is to write a totally legit program, right? And by accident, I have a bug where I keep acquiring more and more memory, right? And let's say I do that on a server. What would happen to the rest of the program running on a server is there will be like slow to a crawl, right? And most programmers at some point in their career might do this by mistake, right? Um, you can use a program called Grind to check for this. We will ask you to do that for assignment 3. Basically, we check for memory leaks. Memory leaks is when you allocate something and you forgot to free, right? But this can be a big problem. I have run an experiment on our server, right? Back when I was a PhD student, that that make my friend's computer slow to a crawl by accident, as well as my friends did to me. Uh, Not definitely not out of spite. We do this by accident. He basically yelled at me out loud like, "What have you done to my computer?" And it's like, "Oh, sorry." And then I basically end the task, right? But this can happen. And Valgrind is your friend. But now let's talk about memory allocation. What is allocation? When a program begins the execution, right, every single piece of your data would take up the space, right? This is not magic. So this class is an introduction to black magic in a computer, and we should stop thinking as everything is black magic because everything is science, right? It has an explanation to everything that we do. White magic, I guess that's also science. Or at least in the computer world, everything is science and engineering. That's why we're here, right? So we should celebrate our collective contribution to make computer faster. So when the program begin the execution, the data actually take up the space, right, in the memory. The program would allocate the memory for all the variables, right? It would basically, what it does is it would basically ask the OS, right, for a block of memory for all the arrays, right? You can also manually allocate your memory for pointers because array, this is handle, right? This is handle when you run a program because I know why is it okay if I can handle, like, let's say I have an array, right? Why is it possible whenever I run the program I can handle allocation right away? What's special about the array? So let me rephrase the question. Do I know the size of my array? In C, do I know the size of my array in C? Yes. Array is defined, it's kind of statically created, and it has a size tag to it, right? So if you create the array inside the program, right, you know the size. So when you run a program, if you know the size, right, do you have to rely on the programmer to manually get the space for that, or can the system software, basically the OS and the compiler, work together to figure out, okay, how much do I have to allocate for the array of this program? Can I do this automatically for you, or do you have to manually, as a programmer, do this? Assumption is I know the size of my array. The OS and the compiler can handle that, right? So when you run the program, these are allocated for you. But how about pointer? Do I know the size of the pointer? Do I know how much space the pointer is using? No, right? So that's where allocation come in, right? And the problem, actually, fun fact, the paper I said I'm submitting in the next 2 hours, actually. I feel bad. So I feel so bad for I should have helped more. But yeah, it's actually about allocation of we call it high order memory, which is the allocation that come from things like special processor that we use on a mobile phone to handle things like camera, right? Camera data. So we're actually working on a paper on this direction right now. But the question is, how can you allocate the memory, right? Because if you think about it, static memory allocation can be done using an array, right? And these are things like array and integer that you define. But dynamic allocation has to be done through a command called Monolog. Monolog allow you to allocate the memory, right? And the way Monolog works is, what is the size? So let me ask you this. What, anyone remember the size of command? What does it do? It can be used to find the size of these type of data. So size of int should give you the size of integer in bytes, right? So that's literally 4, the number 4. Yes. So if you say a equals malloc 10 multiplied by size of int, what is the input to my malloc function here? 40. And I mean, in words, right? What is 40? Is the number of bytes, right? It's number of bytes you want to allocate for A. So whenever you say malloc, whatever follow that is the size in bytes that you want to allocate for that pointer, right? Is it clear now? Just use malloc and put in the size and you get that size. It's as simple as that. Okay, with me so far? This command basically go and find a free space, free location in DRAM. Then you allocate this location for pointer A, right? Free LAN, right? Uh, think of this as the system, the OS. Go and find the empty LAN that would fit, right? 10 integer for A. And then the variable a would take this address, right? Because every single piece of the land in the memory has the address. So what does, if I said this, what does malloc return? Can someone tell me then what does malloc return? It returned the address. Yes, thank you. It returned the address, right? It doesn't return an integer. It doesn't, well, it returned the address. It doesn't return a pointer. It returns the value for the pointer, and the value for the pointer is the address. So again, think of malloc as I go find a free land that A can store the value, and I give the address back to A, right? So here are some example. Oh, sorry. So I can use malloc, right? It's like something like this. Int star I equal malloc size of sure, just for fun. Multiply by 60. How if I do this? How many bytes did I just allocate it for the variable I? 60 bytes, right? How many integer I can store after this malloc using the variable I? 15, yes. So it's basically 15 integer, right? Again, I'm not suggesting you to do this at all. Make sure the size of and the data type match. All right. But this is kind of like the example where you can do this too, because basically malloc takes a number. The number is the number of bytes, and it returns the address. I can use the address later. Now I is an integer pointer, so it can point to 15 different items in this 60 bytes land that I created. All right. So again, the weird format is for your understanding. Great question. Great question. The question is, what if I do I plus plus? Does it go by 1 byte or 4 bytes? How can I tell? That's another great question. So let's go with the first question. Yes, Karan, you're correct, right? So basically, because I say I is an integer pointer, it points to an integer, so it should go up by 4 bytes at a time. So when you do I plus plus, it go to the next 4 bytes, right? And then the second question is, there's a start and end to malloc as well, right? How do we know how much space they take? That's a great question. Anyone want to guess the answer? Can I tell the size of I? How can I tell the size? Oh, is it possible for me to tell the size of I? Can I tell the size of I by some command? The answer is no. So that's one of the things you need to make sure you know as a programmer is that once I do the malloc, make sure you also keep track of the size of the thing you just malloc. Otherwise, you can't tell the ending of this pointer I. All right. Does that answer your question? Just make sure you keep track of that too. Like make sure you keep track of that this is 15 items. And somehow you need to make sure you create another variable, maybe called size I, let's say 15, right? So is it more clear? Is this faster than an array? This is a great question. This is a great question. Um, Let me check if that is blank. No, the next slide is not blank. Uh, how many people think it's faster? And how many people think it's slower? Okay, let me do a poll, right? Let me do a quick poll because I think this is a great question. because it has to do with the performance, which is a question I always. This is something that I like, right? I want to say full results here. All right, open poll. Now let's everyone join in to the fun. You're getting to something interesting actually. Meta is getting to something interesting. All right, before we wait too long, let's wait one more minute. Wait. Let's if you try GCC Monolog, let's wait until the in-class exercise and we go through that together. Is that okay? Yeah. And the reason why I said this is a great question because I think this is this can go if you think about it, right? Is pointer kind of the same as array? Except for array use stack and pointer use the heap. We're not going there yet. But the answer, the reason I said same-ish, because at the end of the day, when you look at the low level and how things are handled, right? If you look at the low level and how things are handled, it's actually quite the same. So the answer is yeah, it's kind of the same. Depending, a small caveat is depending on how you implement the OS, right? And that's a really, really big assumption. Why? Um, no, not yes and no. So in data structure, right, we call a heap, but you can use the heap to represent priority queue. Does that answer your question? I'm not sure if that does answer your question, but priority queue is a type of data structure, and you can use the type of data structure called the heap to implement priority queue. It's basically the queue where you can keep putting things in, but when you want to take things out, it's not first in, first out. But the first thing that comes out of the priority queue is whatever items that has the highest or lowest priority, right? It's like when anyone been to like a like Universal Studio or Disneyland, Disney World in the US or somewhere else before? Anyone? So for those places, right? You can actually, on top of getting the pass to go to the park, right? You can also buy something called priority pass, which basically, if you have that pass, you're gonna be inserted into a different queue that has more priority than other people, so that you can play the ride more often and quicker. You don't have to wait that long, right? But it does cost a lot, right? So priority queue is working kind of like that, where it takes the item with the highest priority first. You can then use heap, which is one of the data structure, to implement these features, right? Um, the reason why I say is the same-ish, right, is fundamentally, if you look at this thing, fundamentally is the same. Pointer point to a location in the address, right? And when you use malloc, you use malloc to create something that looks like an array, right? When I call malloc, what would it look like? My array would look like this. right? This is my array. If I create an array using pointer, it's going to look like this, right? So fundamentally, the abstraction of this block of data in the memory is the same. The way the OS go to that location is also the same. But I have this small caveat that said depends on how you implement the system. Because if you want to optimize, you can actually try to optimize one data type over another as well. So if you think about it, which one is a little bit easier to optimize? Which one do you have a known size before you even run the program? Which one has a known size? The array, right? So if you look at it from the compiler point of view, compiler, what does a compiler do? It does a multiple things, but one of the core thing the compiler do is first it tries to understand what the heck have you been programming, right? What is the code? The second thing it does is based on your code, what can I optimize? So GCC, surprise, it's actually try to understand your code and then optimize so that it spits out the assembly that is actually faster than what would have been just a direct translation. So if you know the size of the array, I mean, there are a few optimization you can do. There are a few alignments you can play around with in the system software and how you map this thing in DRAM. So if you try to be really, really fancy, arrays has more opportunity. I would use the word opportunity because it depends really to make and become faster. Right. Hopefully it's more clear. I know it's vague, but this is actually we are talking into the frontier of how you allocate things and how you would map things in DRAM and how you would manage DRAM, which is right now kind of a topic that is actually really fun to work on, but there are multiple options that you can do. All right. Any other questions? By the way, great question. I think this is actually the first question that ever came up in this iteration of the class. I mean, in system skill. So you guys are awesome. Um, so let's now talk about dynamic memory allocation using pointer, right? This is what it addressed. So one thing that's annoying about the array is you don't know the size, right? You don't know the size. So you can actually change the size of the array using a Monolog, right? How do you do this? You then first the first thing you do is to create a temp pointer. Then you allocate a bigger size range with this new pointer. Then you copy everything and then you deallocate the old pointer. We'll do a demo for this in this class. If we don't have enough time, we'll skip to the in-class exercise and we'll handle the demo in the next lecture. I want to make sure using pointer is more clear. This is my feedback. Usually system skill will have like 4 free slots at the end. This semester I'm gonna use like at least 2 of those slots for extra classes on C to make sure you're comfortable with using pointer, right? But we will do a demo on how to extend, how to make your array bigger, right? Memory deallocation, when you no longer need to use the allocated memory, you need to free them, right? You need to free them. Imagine you try to ask for more and more land, and then you say, hey, I'm not using that part of the land anymore. So a nice person would be like, okay, someone else can use it because I'm not using it anyway. So you should free them, right? This is done by calling the function called free, and you put the pointer name inside. Yeah, I kind of you sell the land for someone, right? Someone can come and use it. That's the reality, right? In our world, right? So land is an investment. That's how I look at it, right? You basically you buy your first home, and anything after that is an investment, basically. You can then use the land for whatever utility you want to use on, right? Depending on your plan. You need to do this to avoid what we call memory leak. Memory leak as the name suggests, your memory will keep leaking out because you keep asking for more land and no one else can use it because you forgot to free. This can happen to your program. It does happen to my program before. It does happen to my program that I accidentally run on the cluster when I was doing a PhD, and then all my friends in the lab yell at me. It's like, what have I done? Right? So we do this quite a few times among me and my friends. Um, there's also heap versus stack, right? So pointer can also point to the heap or the stack. But the stack is an area in the memory where you can use it to handle things that has known size. What are things that has known size? Variable I, J, and K, right? I know the size for sure. Array, right? Because I know the size as well. Anything that is statically allocated, right? Then you also have the heap. Think of the heap as this extensible memory where whenever you malloc, right? Whenever you malloc, the heap gets extended, right? The heap gets extended. And visually, heap is a flat, growable region. You can keep growing the heap. It gets bigger and bigger. Um, can I ask, do you mind if I ask this? So I said that each program can use the heap. So let's say I use multiple, let's say I have multiple program running and each one of them try to allocate for more memory. Would it be chaotic to control who grow the heap at each moment? Would it be kind of chaotic to kind of like, hey, I just allocate something and then that address is mine, and then some other program comes in and try to claim their own address? Would that be chaotic? What if your array that has the size 100, the first 50 elements of your array is yours, and then the other 10 someone actually allocated and that's theirs, and then you start from the 60 to 110? That could be chaotic, right? So that's why virtual memory comes in to help this problem, and we'll talk about this. Yes, it's literally, if you think of the program, every program is at war, right, with each other program to get the memory and to use it. uh this is actually one of the topic of my research area, right? How to manage them. But if you think about it, if you have virtual memory, if you have the way to handle that in hardware, you can fix the problem to some extent, right? So what are the use of pointer? As I said, you can use it to do dynamic memory allocation, right? Data structure such as linked list, tree. Anyone taking the DSOP class? Anyone have taken that or are taking it right now? Yeah. So for those of you who raised your hand, so you might have seen a linked list, you might have seen a tree before. In this class, we will talk about the linked list and nothing else. Uh, because otherwise, if you take the SOP, you get an advantage over the rest of your friends. So will limit everything to linked list, because linked list is an awesome type of data that almost look like a list in Python, but it requires I guess you're comfortable handling of pointers, right? So it's a good practice for using pointer. You can use pointer to pass data into function. You saw that in the sample last Tuesday, right? You can use it to pass multiple data out of the function, right? Oh, if you have the experience playing with a binary tree, you play more in your undergrad for sure. I can guarantee that. Uh, you can also use pointer to return more than one thing. You can also use pointer to point to functions, right? More thing to consider. You also have this thing called void data type, right? Void data type. Basically, void mean nothing, right? So you can have a pointer or a function that have a void as a return type, right? It returns nothing. Basically, it's a function that do something. It doesn't return any value. A pointer can also be a void type. Why? Can I ask anyone here, why would I want to create a void type? I mean, I have the reasoning here, right? Sometimes I create, yeah, it does store the address, but I just don't know by the time I create the variable, right? No matter how hard I try, I have no idea what would be the type of that variable, right? So it store the address. It just doesn't know if I do that plus plus, if I do the plus plus operation, should I go 1 byte? Should I go 4 bytes? Should I go 8 bytes? Right? In many instances of this, it can happen. It can happen, right? I don't know the size of this pointer. I don't know the type that the pointer would point to. I will declare that later. The key here is I will cast the data type later. All right. Why is this useful? Why is this useful? Anyone remember our swap function, right? From Tuesday. Anyone remember that we do in it's yes generic, right? What's the benefit of making things generic? You can reuse it, right? You can reuse the same code as long as you have a new data type. You can do whatever you want with it, right? So one thing I can do is I can do void, right? Void star A, void star B, right? And then I would just implement the function and swap the value of A and B. And then later on, I would cast them so that I know, okay, this is an integer, or this is a long, this is floating point, this is a character. Would that be, would it be handy to just implement a single swap function? It does take an address, but I'm not telling the type yet because I don't know. I'll use it later. And when I use it, I'll define the data type later, right? That's convenient, right? So you can definitely do this. And when you write code in C, especially the code that touch like the Linux kernel and things like the system software, you will do this a lot because sometimes you don't know the incoming data. I don't even know the type, so I just use void star and I cast them later, right? Casting, similar to variable, you can cast pointer types. So int star in front of your variable name would mean that this variable is an integer pointer. We'll do a demo on this when we show you how to work with a function QSort. It's called QuickSort, and it's a built-in function in C. You can use it to sort data. So you can do float star would cast the pointer type to floating point. You can also, the other thing that can come up is const. Const will be used to declare that these things that next to the const is going to be constant. Right? So const int star a means that a is a pointer. A is a pointer. It points to an integer. But when I use a, the integer that I point to will not change the value. Basically, I cannot use a to change the value. I can only point to the value. I can only read from it. This is basically means that read only. We can change the address of A because why? If you want to make sure I cannot change the address of A, I can write something like this. Int star const A. Now the constant is tied to A. So in this case, I can change the content of A, but I cannot change the value of A, right? The value, the address, basically. I cannot change the address, but I can change the content, right? So if I do const in const A, basically now I can't change anything. It's read only, and I can't change the address as well, right? Um, you can use const to actually speed up certain things, especially if you go parallel programming, right? in parallel programming, there's a beauty in making things read-only. For those of you who are taking fun part, I'm not going there in detail right now because it is the content for fun part. And it basically revolves around what is a great thing if we can assume that my data will not change ever, it's read only. Basically, it means that many people can read the data at the same time, right? Yeah, you can change the address in cont in star A, but the value that A points to, you cannot use A to change the value. The value at that location can be changed by some other variable, but you cannot use A to change the value. Is it more clear now? All right, awesome. You can also use const for function declaration as well. And we'll talk about function in a bit when you talk about function pointer. But before we go there, now when you start assignment 2, you're going to run into multiple bugs. And the tool called GDB is your friend. GDB is a debugger tool. I'm going to show you a demo on how to use GDB as well as how to use the make file for assignment 3 in the next lecture. But when you use GDB, you can type in the command GDB to your binary, right? To make sure your binary can be run with GDB, you add -g to the GCC command. And the basic of GDB is this, right? So to start using GDB, you just do GDB and put the binary name in. That would open up a program called GDB and run your code. You can set the breakpoint. The breakpoint, what it does is basically it will go to that point and stop, right? So you can set a breakpoint to a line number on your code or a function name of your code, right? You can even do something like file name, function name, right? Then when you run a program, type run. It will run until it hit the first breakpoint. And when it hit the first breakpoint, you can just go one line at a time. You can do the step. When you type step, you go one line at a time. When you type continue, it will go to the next breakpoint. And you can print values when you stop things, right? So that's basically the gist of how to use GDB. And I encourage you to search GDB cheat sheet to basically work with GDB. The next thing we have to talk about is called function pointer, right? What is a function pointer? Remember, our program is stored in a memory, right? When you run a program, the program get copied. The content of the program get copied to the main memory in DRAM. So your program is there. This means that you can use a pointer, right? Because pointers store the address. It means your program has an address. I can use a pointer to point to your function. For example, this is my code. So let's say this is my code. I have the first thing is called a function. What does a function do? Can someone tell me what does a function do? Yes, it does something. Um, definitely not recommending recommending you making jokes while I'm drinking. Almost laugh like while I'm drinking. It returned that number plus 10, right? Something plus 10. What I can do is to create a pointer that points to this function so I can use it later, but not calling the function through the function name. I will call the function through the function pointer. So this line, sorry, not clear. This line will create a function pointer. What is the name of my function pointer? Func PTR, yes, this is the name of the function pointer. What is the input type of my function pointer? I can tell it by whatever come afterward. Integer, yes. So this tell me the input type. So if I have two inputs, what should I put in here? Let's say I have two integer inputs. One thing I can do is to do this int, comma int, right? It then means that the function takes two input, both of them are integer. What is the sorry? What is the return type of my function that I am pointing to? Thank you. What is the return type? I can tell the return type by looking at the function signature, right? This is the return type. And then I then assign the actual function to this. That's whatever is coming up at the end, right? You see this part where I say ampersand func. This is assign the function to our function pointer. And the next line, you can see how I call the function, right? Oops, sorry. I can call the function this way. Can someone tell me why then I need to do this dereferencing? So I have the function name, right? I have the input coming up, which is 0. The input is number 0. I have the function name. I want the value, right? I want to dereference. Think of the star as dereferencing. Func PTR point to my address. I want the function. I don't want the address. So I first dereference to get the function. Now I have the function. I put in the number 0. So it would run 0 plus 10. Then it would print what? What does this print? 10 and 10, right? So note on function pointer, no need to do Monolog. Why is that the case? When I run the program already has a place to stay, right? So there's no need to do allocation. You can get the address of the function using the pointer, and you can kind of do weird things with that, I guess, if you really want to hack. Not recommending, and the OS likely would protect you from doing this anyway, right? Pointer can also be an array, right? So it means multiple things. You can now have an array of function pointers. You can now also have a 2D arrays, pointer of pointers. And function pointer would operate like a normal functions, and many of the library that you can call like a QuickSort. I'm going to show you during a demo on how to use QuickSort. It required function or function pointer as an input, right? Why is that the case? For example, you want to sort something, right? You can't tell whether you want to sort from highest to smallest or smallest to highest, right? So you can use function pointer for that, right? You can also use this as a callback function. Basically, a callback function is something that say, if this happened, call this function, right? More reference here of the same, right? We're gonna do the sample code for quicksort and do the extensible array. And after the sample code, we do it in class 6. And then go vote this weekend, folks. We have an election. I already told everyone here that if more than 15 of you go vote, I'll make a poll for whether you went and vote or not. I'm not asking who you're voting for, just go and vote. If more than 15 people go and vote, I'll get extra credit for everyone in this class, right? So hopefully there's a good motivation to go and voice your opinion about who should be hopefully improving Bangkok. And now we will do a quick break. We'll resume at 3:10. I'll be on my desktop, and then I'll be doing a sample code. All right. Oh yeah, I record this. It's fine. I mean, I think it's totally okay for me to tell people to go and vote, right? This is within my rights to encourage my students to go and vote, for sure, right? But now I'm gonna do a quick pause because we're gonna do a break we will come back at 3:10 and we will be doing a demo. So while I'm pausing this, I'm gonna switch over to my desktop and share the screen. All right. Okay, so we are resuming. What I just did was I opened a file called qsort.c. And what I'm gonna do is I just asked you guys to give me 10 random numbers. And these are the random numbers that you all select, not me. All right? Just make it clear on the recording. Is that 10 number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, perfect. And then what we're gonna do is we'll try to use a function called QSort, right? But before we go there, let me do some like printing first so that we can basically do something like before sorting, and here is the number, right? I want to kind of make it look relatively nice. So let's say for int I equals 0, I is less than 10, I plus plus. All right, can someone tell me how do I print the number? I will print out, right? And then %d. To make it nice, I would just put a comma at the end. And then I'll put in a of I, right? And then at the end, I should basically do the end bracket and new line. All right. And then I want to do one more thing. After sorting, yes. So what I want to do is I want to use a QSort function. QSort is a function in standard library. I forgot. Oh, you meant this, right? This thing. So if the thing that come after the for loop or an if else is only one single statement, you don't need the curly bracket. Yeah. So you can do that. Now let me put in the documentation for QSort. You see my monitor here? It explains what and how to use QSort. QSort will do the quick sort on your array. It takes first the base, that's your array, the size for each item, the size of your array, and then the compare function. The compare function should do what? The function that compare two elements, right? Let's go back to our demo, right? So here is our demo. What I want to put in is first, I want to put in the array, right? The size of each item. So what's the size of, what's the size of my array? 10, right? The total size of my item. Each one of the item is a size of int, right? And then over here, it has to be a compare function. Some compare function that I have not defined yet. I will define it now. So if I want to compare two number, right? If I want to compare two number, what should be the input type that I'm putting in? The thing is, in QSort, if you read the specification, right? Let me declare a function pointer first, right? QSort needs you to return an integer. You want to create a function pointer. So that's the first thing I do. I create a function pointer. It takes in some input, and can someone tell me what are the two inputs for QSort? Two number, right? I want two numbers. But if you look at the manual explicitly say that your number should be of type const void star A, const void star B. It takes two input. I don't know the type yet, right? So that should be my function pointer. So let me declare the function called int low to high. And it takes const void star A. It takes two input, and I just want to compare A and B. I want to compare A and B. For QSort, if A is less than B, it should return -1. If A is greater than B, it should return 1. If A is equal to B, I should return 0. So how do I do that? If something something return -1, else if something something return 0, else return 1, right? What should go into the first if? The first if, literally, this is what I want you to us to do. If A is less than B, I'm gonna return -1. If A equals B, I will return 0. But would this compile? Is this a correct thing to do in terms of the data type? Yes, exactly, right? We learn about casting. So A right now at the moment is const boy, but what is the actual data type of the thing we want to compare? These are number, right? These are number. So the first thing you want to do is cast A, right? You want to cast A into what? It's an integer pointer, right? And I guess to make it less crazy, I would just put parentheses around things to make sure I align. So this is the value of A and the value of B. Any questions? As I said, I have A and B, both are pointer, right? I give reference to get the value, but it's a different type, so I need to cast from void star to int star. Any questions here? And then I have created a function. One thing I need to do, right, is to say func ptr equals to low to high, because I haven't pointed to the function name I want yet. Oh, is it if it's all right to be that we typecast the pointer and assign to another? Yes, that's okay too. So you can also first typecast star A into the integer pointer and put into some temp variable, right? What if input is not a number? If input is not a number, in that case, right, it would get cast as integer pointer. What it does is literally it will go to that address, get the next 4 bytes, and somehow the computer would drunkenly think that's a number and gets that number for you. So does that answer your question? If your input is some address, but the address it's not pointing to a number, the compiler might give you some warning depending on how smart the compiler is. But if you run it, what would happen is we'll go there, take the 4 bytes, interpret that as a number, and compare for you. All right. That's why I said C has so many things built in that you can make bugs from it that you might not you don't have to be that creative to create that bug. GCC QSort. And definitely error, right? Why? Because compare function, what is a compare function name? Func ptr, right? So let me do GCC again, right? And then run. Now you see numbers are sorted. So it's from 1112, 1150, 420, 69, 16, 10, 1112. You sort it and you get 0, 2, 3, 0, 2, 4, 6, 9, 10, 16, 1112, 1112, 1150. All right. Now, the beauty of function pointer is if I somehow want to, instead of sorting from low to high, I want to sort it from high to low, right? So what do I have to change here? How do I sort this from high to low? With this sign. Yeah, that's it, right? And then in here, one thing I can do is this. So let's do a more elaborate example where I would first sort from low to high, followed by sorting from high to low. So what is the only thing I have to do right before I call quicksort? Now I want to sort it from high to low, which has another function called high to low, right? So one thing I can do is I then can just reassign my function pointer and call the function pointer to point to the function called high to low. All right, let's compile this. See? So in this case, I can write two different functions, have one single function pointer, and I point to two different comparators, right? And then I can use it to sort the number. All right. Now let's actually build an array using a pointer, right? So let me copy the content of my array to here because I'm lazy. I don't want to write it again. So let's say if I need to make this bigger, I can't just hold 10 items. What do I have to do? One thing I can do is to create a new pointer, right? And then let's say I want to allocate the size for this pointer to be 20 multiplied by size of int. So what's the size of my new array? I guess I'll call this new array. 80 bytes, yes, correct. So it can hold 20 different integer, right? And then what I can do is if I want to copy the two array, right? So this copy the content of A into new array. So here's what I can do, right? For int I equals 0, I is less than 10, I plus plus. All right, am I done here? Or do I have to do something else? Am I done here for copying? Copying. What about the other thing that come after 10? I should then reinitialize that, right? Just to be safe. Basically, now I have the array of size 20, right? That I can go back and forth. The first 10 elements coming from the array A, and then the next 10 is just 0. I can use it later. So what if I want to now move this new array, double the size, and now make the array size of size 40? What can I do? How should I do that? How should I do that? Yes, I can Monolog, right? The size 40 multiplied by size of int, right? And then I'll just do the same thing here. I will loop around, right? And from the element 0 to 20, I will just assign the old value from new array to temp, and anything between 20 to 40, temp of I is going to equal to 0. Anything that I do here that I forgot, I now move everything to temp. I now move everything to temp. I want to make sure now new array has the new size. So what do I have to do? You would first need to clear the old array, right? What else? What can I do next? I can do this, right? Okay. Any questions? I guess return 0 just to make sure it completes the int main. Do we free A? That's a great question. Can I free A? A is on the stack, right? So that's allocated statically. You don't have to free A. The time when the program free A is when the main function finish. When whatever function has that allocation, has that declaration of your array, when the function complete, the computer will free that for you. The problem is with heap, with the malloc, it won't free for you. So that's the difference. If you allocate the actual array, finish the function call, the array would get free. With malloc, you have to actually make sure you free them later. All right. Any questions about this code? If we create a new bigger array instead of malloc, will that work? Yes, that can work too. So just to show that there's a flexibility here that you can use array, you can use malloc. You can also build a function that handle the malloc and move to the new array, right? With this approach. Definitely there's a cat right here. I'm trying to figure out like what's that noise. All right, any other questions before we move on to Discord and talk about the in-class exercise? Can I show the debugger? Yes. So how about we do GDB? So to use the GDB, I'll use QuickSort because we compile and run it. Have done it already, right? Add -g, and then I'll just show this to you, right? Before that, let me make sure I know the line number. What is the line number? So let's say I want to make sure I stop right here. I stop like right at this line. That's line number 23. You can tell it on Vim by looking at this part. That's line number 23. So I'll stop right there. Right. So I'm gonna do GDB QSort. No, a.out. So that's our binary. Right? It run the GDB. I can say break 23 that set the breakpoint at line number 23 on qsort.c. I do run. It actually will now run your program and basically report I'm at this line. Func PTR equals low to high, right? So I can say print func PTR. It give me now the address. It give me the address. Anything interesting here? It also give me the type, right? It give me the type of the function pointer. It's a pointer to the function that takes in const void star, return const void star, right? So let's go line by line. Step will now move to line 24, right? Again, still print again, right? Now see the difference. The value change, right? My function pointer. Why does the value change? Can someone tell me why does the value of my func PTR change? Because I just ran this line, right? I just assigned the value func PTR. Before that, this hasn't been initialized. It's just some random address. Now I actually get the address. Can someone tell me what is the function pointer pointing to after I ran this line? Debugger actually tells you the function name, right? low to high. It actually tell you, hey, this is the function name low to high. So I can then step, right? Step, it literally will print, right? Before sort, blah, 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 right? Then I can step again, right? In printf.c, step, something complicated to print, right? And I can continue. The problem with continue is that's the only breakpoint that I set, right? That's the only breakpoint that I set. So if you want to debug more, you set multiple breakpoints. When you continue, it would then move on to the next breakpoint. The problem here is I continue, there's no more breakpoint, so it finished the execution, right? So I can say quit, it would quit the program. I can also, I guess, do break 23, and then I will set another breakpoint at 28, right? I first run to that function pointer, then I say continue. Now it will be at breakpoint number 2, which is right before you call QSort. If I step, again, it would go into the pre-built QSort function, right? So we can continue because that's a long process. And then I can quit. All right, any questions about this? This exercise is going to be really, really, really useful for you when you actually do assignment 2. And when you go line by line by line, make sure you can basically print the value that you want to print. And make sure you get the right number printing out. All right. Any other questions? Sorry. Any other questions before I move to Discord and we can do the in class 6? Before we have no time for in class 6. So that's it for the lecture portion today. So I'm going to stop the recording.